Hi, my name's Manjot Singh. I'm here to talk to you about storage engines, and specifically, what are they, and how do they add value to MariaDB and the MariaDB platform? So, traditionally, you may have used many different database products in your organization. Let's say you may have had some sort of general purpose engine, perhaps Oracle, SQL Server, any of those types, DB2. You may have had, let's say, a high write engine. High write. And this could be, maybe an LSM tree based, maybe something like HBase, Cassandra, something of that nature. Or you may have had a database specifically made for sharding. So a database that's highly scalable and a sharded type of architecture. And then perhaps you pair that with an OLAP environment for analytics or warehousing. So we'll say analytics here. You could have had Vertica, Greenplum, something of that nature, something, columnar, highly analytic, highly parallel type of engine. So you would have different SQL layers for each of these, and you'd have to have different orchestration, different backup methodologies, different ideas on how they run, how they should work, perhaps different application layers. And all of this causes high operational overhead. Well, MariaDB can give you all of that with just the same SQL layer on top. It's just the same SQL, different storage engines underneath, and the ability to use the same orchestration and topologies, and all of this within one binary. So for general purpose, we have InnoDB, which is our general purpose storage engine. And what that does is allows us to control, have highly transactional rights, have foreign keys, full ACID compliance. And again, all of our storage engines are fully ACID compliant and transactional and whatnot. And then for high rights, we have MyRocks, which came from Facebook via RocksDB, which was originally a Google product of LevelDB, just many different projects from the open source community. And then for sharding, we have Spider. And we have another video on Spider, and what that lets us do is have basically a table that references many partitions across many nodes there. And then for analytics, we have our columnar database, which is called Column Store. And Column Store doesn't store data in rows. It stores them in columns, and each of these columns can be queried, where each column is basically its own index. So that's pretty cool. But what you get here is the same replication, the same SQL layer, same orchestration, less operational overhead, and the power of each of these storage engines. And we actually also have a write engine called Aria, which is part of the same SQL layer as well. And Aria is great, a read engine is great for reads. As a read-only type of engine, and it's also highly transportable. So storage engines basically control how data is written, how it's stored, some of the transactional isolation, and many different performance types of variables. And they give you a lot of control and power over how your data is read, how it's written, how you can do different functions on it. So we recommend that you look into all these various storage engines and their power. So how could you use all of them in let's say, a typical application? Well, what I like to do is talk about one of my clients that they're a credit card company. They have a table for all their orders, all their transactions. And in that table, what they do is they're just constantly writing. So they may write millions of rows per day to the end of that table on hot rows. So what we recommend is you could have a partitioned environment where you have MyRocks for those high write, high compression workloads. But maybe you don't want all your historical data in MyRocks. You can pull that over to InnoDB. And MariaDB's InnoDB has many improvements over other versions of InnoDB that may be out there. And InnoDB being that general purpose, you can run more queries against it, and then maybe over time, and you could store 30 days in MyRocks, let's say, with maybe up to a year in InnoDB, and then you could have column store for your long-term archive and analytics. And this gives you quite a bit of power. And we have other storage engines coming in. There's quite a few things out there that you can get, but putting all of this in one server and being able to read all of that, you could put Spider above this, and Spider would just see this as one table. Basically, you would query the Spider table, and you would have these partitions by date. So there's many ways to play with all of these storage engines and use them to solve real-world problems that otherwise may be unsolvable or may be difficult to solve across various vendors. So I hope that helps you and provides you some value. Thank you.